of our trig unit. So after this, we will be going back to the textbook to learn a couple more chapters of material from the textbook, and then we'll be doing some kind of random topics after that for the rest of the year. But this is our very last trig lesson. So we'll do this one. On Monday, we'll be then reviewing these lessons about trig, and then on Tuesday, we'll have a quiz to wrap everything up. Today's lesson, I think of as being exactly the opposite of yesterday's lesson. So in yesterday's lesson, you were given a trig function and an angle, and you needed to find the fraction from drawing a triangle picture. Today, I'm still going to give you the trig function, but I'm going to give you the fraction, and your job is to find the angle. So we've actually done inverse trig before because we did it on our calculator. Anytime on our calculator that we press the second and then a trig button, we were doing this lesson, we're going to be doing inverse trig again to solve for angles. But we're going to be using these special angles, so we're not going to be typing it into the calculator then. I think of this lesson kind of like Jeopardy. So on Jeopardy, the contestants are given a category, and then the clue that they're given is actually an answer, and that's why when they give their response, they have to phrase it in the form of a question. What is, who is, that kind of thing. So yesterday, I gave you the category and the question, and you gave me the answer, which is a fraction. Today, I'm still going to give you the category, but I'm going to give you the answer, and you have to give me what was the question. Okay? We're working our way back to that angle. Since we're doing this for special angles, the same pictures that we used yesterday are going to be really important here. So our unit circle, our 30, 60, 90, and our 45, 45, 90 are going to be where all of our answers come from. That means our set of possible answers is very limited. It could be around the circle, so it could be 0, 90, 180, 270. That's it around the circle. It could be from the 30, 60, 90, so it could be 30 or 60. Or it could be from the 45, 45, 90, so it could be 45. There are only 7 possible answers. So you're going to get the same answers over and over a lot. So don't be surprised and be like, I'm getting way too many of this answer. There's only 7 possibilities. So we'll only have that kind of small bank to choose from. To do these problems, we're going to start by thinking about SOHCAHTOA, since I'm giving you the trig function. So for sine, what is SOHCAHTOA? Opposite over hypotenuse. Then we want to line up these pieces and try to locate the stuff in a triangle. So which triangle has a hypotenuse of 2? The 30, 60, 90 has a hypotenuse of 2. Oh. So knowing the hypotenuse helps us locate which triangle we're talking about. Then, within this triangle, we need to select one of the angles. To do that, we're going to look at the top of the fraction and say we're looking for the angle that is opposite of the square root of 3. So which angle is directly across from the square root of 3? The 60. So 60 is our answer. You will not have a calculator with you on your quiz. Yep, it will work to just type it in a calculator, but on the quiz you won't have a calculator.
So we can check our answers.
You can check your answers with a calculator, but I would really suggest not doing it with a calculator because that will not prepare you for your quiz.
That's okay.
Yes.
If you just look at on a sine or a cosine, if you just look at the one on top, you basically assume which it is.
Not necessarily.
It's like doing math and addition problems.
I think it's DA.
The directions for this question. The directions for this question ask us to evaluate it in both radians and degrees. So far we have a degrees answer here that this is 60 degrees. We need to turn this into radians as well and give both answers. What was our conversion to move back and forth between degrees and radians?
2 pi. 2 pi over 180.
180 is pi. Okay? 180 is pi was our conversion to move back and forth between them. So what we're going to do is say pi should be a part of our radians answer, and pi is 180. So 180 divided by what would give 60?
3.
180 divided by 3 is equal to 180 was our conversion for radians and degrees. So if pi is 180, 180 divided by 3 is the same thing as 60. Okay, so you need to give both a degrees and a radians answer for every question. A little. For the next one, we're given a cosine. What's SOHCAHTOA for cosine? Adjacent over hypotenuse. We want to then think about our hypotenuse as being a square root of 2. So which triangle has a square root of 2? 45. Then I need to pick an angle that is next to a 1. From your triangles, you may never select the 90 because 90's opposite is its hypotenuse. So 90 causes some problems in a triangle. If 90 is an answer, it will come from our circle, and we'll see how that works in some later examples. So in the 45, 45, 90, our two options are 45 or 45. So we're very limited there. Our answer here is 45. You may not select 90 out of a triangle because 90's opposite is the same thing as the hypotenuse. To convert, pi is 180. How many times does 45 go into 180?
3, 4.
4. For the next one, we are not given a fraction. It is helpful to have fractions to think about SOHCAHTOA. So whenever you are given just a whole number, divide it by 1, because dividing by 1 doesn't change anything. But it now gives us a fraction. What is SOHCAHTOA for tangent?
Opposite over adjacent.
Opposite over adjacent. So I need a triangle that has an angle that is both next to a 1 and across from a 1. The triangle that has two 1s in it is the 45. And a 45 is both next to a 1 and across from a 1. So our answer is 45, which once again goes into 180 4 times. You'll be reusing these same answers a lot because we don't have a lot of options for our answers.
So that's the final answer.
Sure. How practical are you? Just to kind of practice like
That's a good question. How practical are they if we can only use certain angles? I guess real world practicality, maybe not so much. I mean, I guess I don't know how many times, like in building or designing something, you would necessarily use these triangles. But I kind of a skill to practice. This one we're given sine. What's SOHCAHTOA for sine? Opposite over hypotenuse. Hypotenuse of 2 is which triangle? 30, 60, 90. Opposite of the 1 is the 30. So we use the hypotenuse to locate which triangle, and then we use the other piece of information to locate which angle within that triangle. 30 goes into 180 6 times.
You just always do it into 100.
Because 180 and pi is our conversion. This one we're given cosine. What is SOHCAHTOA for cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. Which triangle has hypotenuse 2? 30, 60, 90. In that 30, 60, 90, which angle is adjacent to the square root of 30?
30.
The 30 is right next to the square root of 3. And 30 goes into 180 6 times.
Is there gonna be like cosecant?
Yeah. Yep. In your assignment, you will be given cosecant, secant, or cotangent ones. So then you'll want to think about their reciprocals.
Yeah.
Tangent is square root of 3. It's a whole number. We want to work with fractions, so we're going to divide this by 1. What's SOHCAHTOA for tangent? Opposite over adjacent. So I need to find an angle that is opposite of a square root of 3 and next to a 1. So straight across from the square root of 3 and next to the 1
60.
is the 60. Goes into 180 3 times. This one, if I set it up as a fraction, make it over 1. What is SOHCAHTOA for sine? Opposite over hypotenuse. Which triangle has a hypotenuse of 1?
45.
None. Trick question. Neither one of them. There are ones in both of the triangle, but a hypotenuse is either 2 or square root of 2. We don't have a hypotenuse of 1. So this doesn't work. If it doesn't work in a triangle, that means that it must come from the circle. So in our circle, all the points are cosine, comma, sine. So in this question, if I'm given the sine, that means I'm given the second part of that point. So where in the circle would I find a point that has the second part of it as being 1? Thinking about algebra, what does the second part of the point tell you to do? Go up or down. So this tells us to go up 1. And which angle line is that? That's our 90 line. So on the 90 line, the second part of the point is 1. And we cared about the second part of the point here because we were asked about sine in this question. How many times does 90 go into 180?
Twice.
If you have a negative in your problem, it's definitely going to come from the circle. We're not going to work with negative triangles for this type of problem. So if you have a negative, you can assume that's going to be coming right from your circle. So in the circle, the points are cosine, comma, sine. So on this one, if I'm given cosine, I'm given the first part of the point is negative 1. Where in the circle is the first part of the point negative 1? On the left side, because negative 1 in the first part tells us to go backwards 1 point. And what angle line is that?
180.
180. And 180 is pi. If you are given a 0, it definitely comes from a circle because there are no zeros in the triangles. So if you're given a 0, this is definitely coming from the circle. When we evaluated tangent in the circle, if the points were cosine, comma, sine, how did we get tangent?
Sine divided by cosine.
Sine divided by cosine. So tangent is a fraction, so we need this thing to be a fraction, so we'll put it over 1. The top should be sine, the bottom should be cosine. So that means our point is 1, comma, 0. Cosine, comma, sine. Where is the point 1, comma, 0?
0.
On the 0 degree line.
Could we just have known that was 0?
Could it be 360?
It could also be 360, and then we would call it 2 pi.
How would you know?
So there's 2 answers.
Either answer would be correct.
You said it could be the answer.
But
Okay,
if
well,
0
what's
was
the
the
other answer that it could be?
360 or 2 pi, because those are the same line.
Oh,
If it's 0, is it always 0? Is it just
No.
tan?
so
It's gonna be 720.
Tan 0.
Yeah, but why would we?
I would question.
To ask questions.
Is it always going to be 0 if it starts out 0?
Your homework is the last worksheet in your packet. I think there's 10 questions.